Can we have a volunteer pray for us, please, so we can start the session?
I pray
Okay. Thank
in the name of the Father, of the Son, and the Holy Spirit. Our Heavenly Father, as we come before you this day, we thank you for being with us from morning till now. As we're going to start this session, I pray that you may be with us and you may protect us so that everything we learn from this session, we may be able to use it in our life. And also pray that you may give us the strength to stay awake and also give the speaker the strength to teach us. In Jesus' name, we do pray, believe, and trusting. Amen.
Amen. Thank you so much, Mandela. So I'm just going to start sharing my screen. So with relation to the assignment, I was able to see that some of you had not yet finished that assignment. Also, I haven't received any, so I'm assuming we haven't been able to do that. So I will add more after this session, and then you can just submit with what we did before. So if you encounter any problem with the assignment, remember to communicate that. Maybe there's something that you have encountered while trying to solve it out. Just make sure you communicate that so that I can make sure that I help you out. There are some of you who will reach out to me for assistance, and I'm always there to help you out. So yeah, don't be afraid to, yeah, you can just text me on WhatsApp and I will be able to assist where I can. Okay, so I'm just going to start off from the MPG. This is where we were last time, but I won't do all this. This is what we did last time, so I will quickly I'll just run the data set, yes, but I believe we got to the facets. We got to the facets, unless I'm wrong, though I believe we got to facets. So wait, into maps. So just make sure, although I believe by now your art studio is already running and everything. And I think did we look at the start function? I believe we did. Do you guys remember if we looked at the start function? I believe we did, yeah, and even sent you an image. Where are those assets? I think I've misplaced them somewhere. I start with maps. I don't want to have content here. So yeah, just remember you can also with the repository links I sent for GitHub, you can find all this there, and you can just be able to use that as a guide to get to that point. So I don't know where those facets are, or maybe I was past facets. I think I'll just start with the mapping because I feel like we did the start and I sent this image. Let me just confirm. Yeah, I definitely sent you this image. So with that being done, we are going to start off with mappings. In the lesson, I did position identity. Okay, we can start from the start bin, I believe. Yeah, So you can decide number covering, but you can just start there. So we said the start bin, or the start bin is used to, the start basically helps us with different, with sorry, with some types of some types of geoms, like the bar chart. So you only give it one value and then it will give you a count, which will now produce the remaining value. So let me just get that data set, the diamond. So this is why we should be finishing up a class, so that we don't have this confusion. That is NPG, diamonds. There's diamonds. Yeah, it is. So let us start from there, from the dataset diamonds. So yeah, that is our dataset. You can see it has given us a small table, which is just a data frame that fits the specific view that we have, and it gives us a summary of what we have. So it doesn't have everything that is contained on the dataset, and you can even see it tells you 53,930 more rows at the bottom. So that's what a table does for us. So we can go ahead and create a ggplot with a bar chart where the x-axis has cut. So you can see we haven't declared the, where we have the aesthetics, where you have declared the x-axis. We haven't declared the y-axis because I have to find the ggplot. Okay, I need to install that package again. Yeah. So to install the ggplot, I use the ggplot too. So I'm just going to run that. And I'm also going to, okay, just give it a minute. Okay, so I believe that is done. Okay, it's not on, almost. Yeah, so that's done, and I believe it has also loaded up the package. Yeah, library install. So I believe that has just, but I can just do it just in case to ensure. So let me go, as that is happening, let me just go down to my data, to where the commands are. The diamonds. Yeah, here are, here they are. So yeah, that is almost done. So if you have a question, you can drop it in the chat section, or you can just unmute yourself and ask. Yeah, so that is done. So let us run this command again, line 151. So if I run this command again, let's see the output it gives us. So let me just increase this plot view. So you can see how our plot looks like. We have the cat. So remember, we only declared the x-axis to have the cat. We didn't declare the y-axis, and with that, that is where now we realize that, yeah, we said only the x-axis to have the cat. So using this start count, it's able to count that data and give us, count the rows of that data. So for the fair, how many rows are they there? For good, how many rows are they there? For very good, how many rows are they there? For premium, how many rows are they there? And for ideal, how many rows are they there? So the compiler does that for us and gives us as a count. So I remember in high school, this was like a frequency. So it's just that. That's what is happening in this case. This is at the bottom. Okay, the top. So yeah, so we say that this is because every geom has a default start and every start has a default geom. This means you can typically use geoms without worrying the underlying statistical transformation. So there are three reasons why you might need to use start explicitly. That is, you might, in case you just wanted to declare it, you don't want to use what the compiler is going to do for you. So it's basically if you want to override the default start, just like we have seen ours use the default start, and then let us change the start of geom bar from count, the default, to identity. Probably you don't want it to be this count, you want to override that count. So you can define that explicitly. And then this let us maps the height of the bars to the raw values of the y variable. So let us see how that can be done. So we created a data frame. I came ahead and created a data frame here, which was df cat frequency. I gave it several values. So if I run this, let's give an error data. Okay, let us see if it will run first of all. Okay, it has refused. Sorry about that. It has accidentally gone to the bottom of my. So yeah, here it is. So df cat frequency. Yeah, so there data must be a data frame or other object. Oh, I remember I counted this and I didn't solve this, so I'll just solve it. But you can just see. I won't solve it now. Matters of interest of time. Have I scroll to the bottom of the screen again? Okay, yeah. So I think I forgot to solve this. But you can see now for this, I come ahead and define it explicitly. I have my data demo, and then geomba mapping aesthetics x is equals to cat, y is equals to frequency, and then start is equals to identity. So when I'm supposed to run that, it's supposed to give me a new histogram. So I'll sort that out and send you the rectification. I think I'll note that down so I don't forget. So you might want to override the default mapping from transformed variables of aesthetics. For example, you might want to display a bar chart of proportion rather than count. So how do you do that if you want to override the default, just like we saw with the aesthetic? So here we have the x is equals to cat, the y is equals to start, prop, so proportion, and then group is equals to 1. So if I run this, let's see what will happen if we do this. So you can see now, we actually did this last time, but it's okay. Just take it as a recap. So this is what has happened. So we have our x being the cat and our y being the prop. So that is what has happened. Yeah, so you might want to draw greater attention to the statistical transformation in your code. For example, you might want to use stat summary, which summarizes the y values for each unique x value to draw attention to the summary you're trying to compute. So probably as a developer, you just, or as the data scientist, you just want to get a summary the y-axis with reference to the of the y-axis with reference to the x-axis. So how can you be able to accomplish that? I'm going to stop using that drop down. Yeah, so I'm going to come ahead and say ggplot data is equals to diamond, start summary mapping aesthetics, x is equals to cut, y is equals to depth, function minimum is equals to mean, fun max is equals to max, and fun is equals to medium. So you can see I'm getting summaries of the y value with reference to the x-axis. I want the minimum, the maximum, and the medium. So if I do that, what output do I get? Okay, yeah, so you can see this is what happens. We can be able to see various outputs being displayed for that. Able to see the maximum, the minimum, and the medium, and the median for each, not the medium, the median for each value. So you're able to see the maximum for this, the minimum for this, and the median. The maximum for this, though, is it medium, or let's confirm that. The median. Okay. So yeah, so we are able to see for each data set how it is displaying. Yeah, so you can even get the mode. No, I think the mode will look a little bit different because it will be now, it will actually show you the mode and all that. So any question up to there? So you can use the stat bin, which is provided by the ggplot. Each stat is a function, so you can get help so you can just use the stat bin question mark preceding that to just get. Don't need to do my compiler. Yeah, it's okay. So you can see when I say quotation mark stat bin, it gives me these options. We have the geom, frequent poly, ggplot histograms, frequency, polygons, description. We have the usage, the NA. This is called not available, remove is equals to false. So it means it will also print values that are not available. If you say true, it will skip those values when it's displaying your output. You can be able to see the histogram. That's the histogram. That was the polygon, the frequent poly, and then we have the histogram. Remember when last week, we checked about stacking position. So show legend, remember it just gives you a summary of whatever is going on with your data set, and then we have the start bin. So the argument mapping, you can see that this is something we have looked at, mapping the statics. We have the data, what you want to use, the position. Yeah, so the NA remove, missing values are removed with a warning, true missing values are silently removed. So what it means is that it shows you, or probably it asks you, you have this row has a missing value, do you want it to be displayed, or do you want, but the main thing is that if you're displaying a data set, the na.rm, it will also display whatever is not like na values. But if it's true, it won't display those rows. Then you have the legend. This includes just giving us a description of what the aesthetics are, and that is something we have also looked at. There's inherit aesthetics. It overrides the default aesthetics, and then bin width, the width of the bins. So this is something you can be able to look at just by typing that command question mark start bin. You can be able to just learn more on that, you can see there's a lot of stuff that you can be able to look into that. You can even be able to practice. These are data sets which are already accessible to whichever data set it will give you on this side, especially with the help command. Those are data sets that are already there available in your R Studio. So like the diamonds, that's something that is there. We didn't have to import it or something. Yeah, so this, it even shows you commands you can use just to be able to practice on that. So that is something I would advise you to practice on and to look into so that you can just learn more on that. So where was I? Start. Yeah, start bin. So now let us get into position adjustments. So you can color a bar chart using either the color aesthetics or more usefully fill. So I know this is something that you have come across, fill in CSS. So that is not really something that should surprise you when we say fill. So what happens when we say color cut? So wait, our data is diamonds. The geom, it's a geom, so it's a bar chart, a bar, a bar graph or a bar chart. Mapping is equals to aesthetics, where we have X will be the cut. So remember, it being a bar, we don't really need to put the Y value unless you want it to be specific to how you want to customize it. But the compiler is just able to do that for us to count. And then now we to come to the number of rows and give us the count. And then now we have the color, which is equals to cut. So let us see what that does for us. So I think it will show us both plots at the same time. Also the one with fill is equals to cut. So we should just be on the lookout for that. So this looks like fill. Clearly you can see the color has definitely filled each X value. So, and putting it distinctively. So we have this being the cut option. So you can see it's basically, it's like it takes the outline. It takes only the outline. So I believe the fill is a little bit more distinctive than the cut. Is this the wait? Yeah. So that is that. Just wanted to confirm something, but yeah. So you can see the difference between the cut and the fill. So I would definitely go for the fill. So note that what happens if you map the fill aesthetics to another variable like clarity, the bars are automatically stacked. They are placed on top of each other. Each colored rectangle represents a combination of cut and clarity. So let us see what happens is if instead of putting fill is equals to cut or color is equals to cut, now we put fill is equals to clarity. And they have said that this will not be a combination of cut and clarity. Remember, cut was just on the border. So let us see how that is going to be different. So the variables are still the same. So let us run that. Yeah, so we can see it stacks on top of each other and it goes ahead and gives the clarity. The data set had a clarity variable. Let me just confirm that. Okay, let me show you that. I'm sure it had a clarity. So what can I do? Okay, yeah, let me try and write you diamonds. Yeah, so let us run that. Hope it allows us to do that. Wait, I hope I haven't mixed that up. not, I can put a question mark before it. Okay, it's doing its own thing. So let me just query it instead of doing that. Yeah, so here is our diamonds data set. Wait, yeah. Yeah, so you can see it has clarity as one of its variables. It has the price, carat, cut, color, clarity. So it measures how clear the diamond is, L1 being the worst to, I think this is 1F or IF being the best. So that is what they're looking for. So they're trying to, so you can imagine even the diamond that is fair has its own clarity, just like the diamond which is good has its own clarity, whichever is very good has its own clarity, the premium has its own clarity, and also the ideal. So where is the data? I think it has run a code, another code. So let me just make sure that we are at par. Yeah, here. Oh, I was running the one below. So yeah, we want this part, field clarity. So now we are distinguishing the clarities. And remember, each X value has its own clarity. So that's why you could see that they're stacked up because each X value has its own clarity. And you can see now it shows us where the clarity with the legend, it shows us the ranges of the clarity. You have L1 being purple or dark purple or purple, and then we have IF being yellow. So each X value has its own clarity. The fair one probably it doesn't have IF, so meaning it's not very good. And then you can see ideal also, as much as it's ideal, it's not, it also has its own level of clarity, though it's greater than all the others. So that is something we can just, a conclusion we can make from that data or that command. Do you have a question so far? Let me just try using my phone. Do we have a question so far? Any question? Okay, if there's none, we just move on. So we now have I'm sorry for scrolling up and down each and every time. Yeah, so here we were. So we were now looking, so the stacking is performed automatically by the position adjustment specified by the position argument. If you don't want a stacked bar chart, you can use one of the other options, identity, dodge, or fill. So position is equals identity will place each object exactly where it falls in the context of the graph. And then this is not very useful for bars because it overlaps them. So to see that overlapping, we either need to make the bar slightly transparent by setting alpha to a small value, or completely transparent by setting fill to not available. So let us see what will happen. So we can just remove this command. We don't need it now. So we have ggplot, data is equals to diamonds, mapping aesthetics is equals to aesthetics, where x is equals to cat feed is clarity, plus geomba alpha is equals to 1 over fifth, position identity, ggplot, data is equals to diamonds, mapping aesthetics, x color. So this is another ggplot command, not one. So if I just, okay, let me just read it all. So here the fill is not available, and then the position is identity. So for this, our fill is clarity. So this one, you're not specifying what comparison you want, and then you're only making it transparent. So let us see what will happen with that. Just put that there. So yeah, so you can see, so for the first one, remember, okay, to the bottom. So for the first one, remember we have our fill is equals to clarity, and our alpha is 1 over fifth, and the position is identity, but alpha is for transparency. So we make it slightly transparent, setting alpha to small. So I believe this is the second code, mapping. So it didn't print one. So let me just run this code. I run the one below it. Let us just run that here. This is what I'm looking for, because our alpha is for transparency. So you can see how that works now. So we have this color, which is like a lighter shade of purple, or whichever color that is L1, and we have this color being IF. So you can see this is not really good analytics, and you can see the overlapping. You can see it overlaps to the point that it produces its own color. So like this is not defined really on the legend. And even if it is there, it has definitely mixed up with another color to now even become more profound. So that is not a good way of analyzing that data. So let us run the other one. It's a, so no, this is the other way around. So yeah, so and now we can have, let us run this where we have the fill is not available, and then the position is identity. So let us see what will happen with that. Yeah, so this gives us this code. So you can see that overlapping, okay, that I was talking about. Also there's some overlapping here, and you can see with the fair there's some overlapping, also with the good. So it really becomes hard, because you can see for this purple is here, and then there's purple here. So it makes it hard for you to be able to really make conclusions with that data, and also it doesn't look visually like the user or somebody who is not understanding what is going on can be able to quickly, even you who is knowing, it makes it hard for you to quickly make conclusions from that data. So yeah, so that's why you saw us have a warning that this is not a very useful for bars, because it overlaps them. So you can see we have seen both those overlapping. So yeah, I hope that um, point has been driven home. So in case there's a question, just go ahead and ask. Okay. So the identity position adjustment is more useful for 2D geoms like points where it is the default. Position is equals to fill works like stacking, but makes each set of stacked bars the same height. This makes it easier to compare the proportions across all across the groups. So I believe this is something we were able to see, but we can just run it again. So they say position fills field works like stacking. So it makes it easier to compare our proportions. So let us run that. We see the difference. So that is how our output looks like. So you can see they all have now a height that you can be able to analyze it more better. So you can see there's the IF here, the IF clarity. You can see for this one, it's totally small, but it's there. And then now we come ahead, we have the VVS2, the VVS1. You can just see the distinction. I think that is very clear. You can easily see the distinction from what we had before. So this is definitely a better way of analyzing that data. Anybody with a question up to that point? So the difference between this one and this to show the one before. Yeah, this one fill cards. You see this doesn't have position, so you could see for this, and if I can just go back. Yeah, you can see how our code looks like. And the good thing with the position, even note how the y-axis is going to be displayed. Note how the y-axis is going to be displayed. You can see what is happening. So you see, it's easier for you to analyze this, you know, and you can see all of them have just been given the same count roughly. So it's easy for you to know how that data set is behaving. Yeah. So, and that has been achieved by this code. Having the position, this we have fill the clarity and position is equals to fill. So let us see the position dodge. Position dodge places overlapping objects directly beside one another. This makes it easier to compare individual values. So let us run that code and see how that is going to look. Yeah. So you can see how the dodge looks like. Sorry. Yeah. So you can see now this is totally different. Each and every value has been placed individually. So you can see now for like the IF, you can see with the fair category, you can know which is which. And this is definitely easier to analyze. And I think this is also a strategy that is used even in our social media. If you go to analytics, even on Facebook, I believe this is something you can encounter there. So this is a great way and an easy way of analyzing data and making conclusions. Just directly by looking at it, you can be able to make that conclusion directly without being confused. Where is this color ending? Where is this color? And so this gives you direct information. So I prefer that's way better. So remember that has been achieved using the dodge position dodge. So the values, um, the values of the this is called, okay, the values of the, this, I think this is giving me values for the mpg. So the highway miles, I think, and displacement of engine are rounded so the points appear on a grid and many points overlap each other. This problem is known as overplotting. This arrangement makes it hard for the data to see. So you can avoid this. I don't know if, yeah, so I'm coming, wait, back to the NPG. Yeah. So I guess it just explains more. This point was just to explain more about overplotting, especially with the scatter plot, and also this where a scatter plot can, the points can be overlapping each other. So that problem is called as overplotting. And I think we looked into this where we use the jitter, position jitter. It adds a small amount of random noise around each point, and this spreads the points out because no two points are likely to receive the same amount of random noise. So that is something we have been able to achieve with the previous data sets. I don't think this is something we have not encountered. So this is one without jitter. So let me just show it to you. So you can see the points are kind of overlapping each other. So to get rid of that, whenever you're analyzing data using a scatter plot, come ahead and use the jitter. So yeah, if I run this now, so the points are a little bit distributed. Wait, I think this is the one without jitter. I mean with jitter. Let me just confirm which code has been executed by the compiler. I think the next time, even if we don't finish a unit, a topic, I will separate that content to prevent this back and forth. So let me just put a space there. So let us run this again. So this one is the one without jitter. And then, no, it can't be. Yeah, this is the one without jitter now. And then this is the one with jitter. It creates a space. So you can see this is more easier to analyze than this one. So that is with scatter plots. So yeah. So ggplot2 comes with a shorthand for geom points. Position is equal to jitter, geom jitter, which is something we have used. Okay, we have not used it. Ours was position jitter. So the short form of that is position geom jitter. So let us get into coordinate system. So the default coordinate system is the Cartesian coordinate system, where the x and y positions act independently to determine the location of each point. This is something you have done with graphs. There are many other coordinate systems that are occasionally helpful. So chord_flip function switches the x and y axis. For example, if you want the horizontal box plots of a long label and it's hard to get them to fit without overlapping the x-axis, you can use that chord flip. Sometimes you can have a bar plot, just like the one we had for diamonds, but you don't want whatever value you have on the x-axis to be on the y-axis, and whatever value you have on the y-axis to be on the x-axis, so that now your graph looks like it's landscape. It's no longer a portrait orientation, it looks landscape. So that's where you use the chord flip. Sorry, the chord flip. So let us run this code. So we have the box plot, the normal box plot without the chord flip, and then our second code here has sorry yeah, our second code here has the chord flip. So mapping aesthetics x is equals to class, y is equals to highway displacement miles. So draw a box plot, and then now for this plus chord flip. So let us see how that will be executed. Yeah, so our y is yeah, and our x is class. So you can see how that looks like. We have the two-seater, the compact, the mid-size, the minivan, the pickup, and the subcontact and SUV. Also, just when we are here, you can be able to find like the two-seater. You can be able to know that this is the median. You can be able to know which one is on the lower quartile, the upper quartile, using this plot. So that is usually helpful for analysis with that. So especially this. So let us flip our values and see how that will look like. Yeah, so here it is. So let us flip our values and see how that will look like. Yeah, so you can see now whatever was on the x-axis is now on the y-axis. So you can even see when once we put our data like this, we realize that when it was landscape, there's a high possibility that that data was not being displayed in wholesomeness. But now we are able to see that data well. We are able to see that data well. So yeah, that is that. And make conclusions from it. So that is how you do that. You use the chord flip function. So we have the chord quick map. Set the aspect ratio correctly for maps. This is very important if you're plotting spatial data with ggplot2. So let us now we want to use this package map. So let us do that. So install packages maps. So that's the command we shall use. So let us just give it a minute. So in case you have a question, you can drop it in the chat section, or you can unmute and ask the question or a concern. Yes, you have a question or a concern. Oh, okay, is it finished? Not yet. Okay, it's almost. Yeah, so it has even loaded up the library. So I have loaded up that library. If I do um, no, if it's HA, I should have done it below. accidentally restarted all this. So, yeah. So we have the data frame of a map data. So I have just queried that information so we can just be able to learn more about this data frame. So easily turn data from the maps package into a data frame suitable for plotting in the ggplot tool. So it gives you the map, region, exact, blah, blah, blah. And then the map, name of map provided in the map package. This include maps county, maps France, Italy, maps NZ, I think this is New Zealand, I guess, and then map state, maps USA, maps world, maps world 2. So the region, new subregions include defaults to, which includes all subregions. So it gives you something that you can just be able to look up to. So yeah, it also shows you examples on how you can be able to do that. So you see, this is something you can be able to learn. So for example, let us click on Map Italy map. So this is an Italy database, data Italy map formats, references. Okay, so Map Italy to call that out. So this was the one I had tried to look for maps. So maps, world, regions, boundary, interior. So you can just be able, you can be able to use also R to play around with maps of different areas in the world. So that's just something I wanted to show you. We are just going to use the New Zealand one for now. I'm just going to show a brief demonstration. So you can go ahead and also look for any other country, and you can use now the map data to guide you. You can use the map data to guide you. Yeah. So remember, you can use map county, France, Italy, state, you say world. So you are free to do that. So make sure you just looked into that and see if you can find Kenya. So yeah. So yeah, so we had already loaded up that this had already linked to 57 New Zealand map data New Zealand. So that is what I have used NZ. So ggplot NZ aesthetics long latitude group is equals to group plus geom polygon, and then fill is equals to white, color is equals to black. Let us look at what that means from I should be getting some guidance. So let me go to see if this will guide us here. Okay, it's not. Yeah, come back. So just click on map world. There's one which had more information. Okay, if I can't find it, it was for world. Like it had more information, resolution wrap, add plot, call, fill. Yeah, orientation. I believe this is the one. Projection parameters, boundary, regions. Yeah, I feel like this had more. So maps, yeah. So we had now our database, maps, regions, blah blah boundaries. So it gives you the different options you can use: interior, projection, parameter, orientation, fill, call, plot. So we can see the database is in which database we have seen. We have France, Italy, World 2, World 1. So you can check to see the difference. Regions, name the polygons to draw, so you can check into that. So Norway, this makes go to negative expressions like don't draw this, which means Norway accepts the islands of that word. And then we have exact, it's true, only exact matches with regions are selected for drawing. And then boundary, if false, the boundary segments are not drawn. So definitely know if something is a map, you need to know the boundary. And then we have interior, if false, interior segments are not drawn. An interior segment is a line segment on a map that bounds two of the polygons to be drawn. So projection, character string that names a map projection to use. Um, so you see all about ratio and projection. Ratio chosen so that the longitude and the latitude scales are equivalent at the center of the picture. And then you have parameters, numeric vectors of parameters. Okay, basically you guys can see all these. Orientation, a vector C, longitude, latitude, rotation, describing where the map should be centered, and a clockwise rotation in degrees about its center. And then we have the fill, logical flag that says whether to draw lines or fill the areas. I think that is clear and self-explanatory. We have call, which is a vector of colors. So you can just be able to look at that. Plot, logical flag that specifies whether plotting should be done. And then add, logical flag that specifies whether to add to the current plot. Probably want to add something, a layer to that specific map you have already drawn. Yeah, so this is something you guys should take your time to look into. So you can see there's so many parameters. Just take your time and look into something. I believe like maps, this is something probably they use in the army, in the marines. So yeah, I believe this is important information. You need to be able to know how not just you, even me, for us to just be able to know how to analyze, how to use Art Studio to analyze maps and maybe get data from that. Maybe is this area, how much desert area do you have, how much land area do you have. I feel like that's information that can be able to help us out. So yeah, we have that. Wait, we haven't run this. Okay, let me now run this. So I'm plotting New Zealand long and latitude in my X and Y's group. Geom polygon fill color white, color black. So my border will be black. So that is what has happened. But you can see it's not really fitted in our, I know we can see it all, but the scaling is a little bit off. So let us improve that scaling. So how do we improve that scaling? Now you're going to use the code quick map. That is what you're going to use, the function. So you can see how that looks like now. You can see how that looks. It doesn't look stretched. It looks a little bit realistic. So that is what the code quick mark has been able to do for us. Anybody with a question up to that point? Anybody with a question up to that point? So it's called quick map. Set the aspect ratios correctly. It sets the aspect ratios correctly. And for maps, this is very important if you're plotting spatial map data with ggplot2. So I believe we have seen how that has been able to display differently. So we also have the code polar, uses polar coordinates. Polar coordinates reveal an interesting connection between a bar chart and a coxcomb chart. So the best I can do is show you how this coxcomb chart will look like. So, but here I will use Diamond's dataset. And you can see this is a combination of them is if they're in a diagram. If I keep talking in theory, it won't be as realistic. So flip, of course, our bar chart now has been inverted. We have the x values, the cut. We have filled the cut, and it has given us our count. We don't have a legend this time. I've given it as a false. It is one. So we can be able to see how that is looking like now. So let us see that using now the coxcomb. The coxcomb. So that is what we have here. It looks like a pie chart in a way. So that is our coxcomb. So it's representing this data, but now in that form instead. So I don't know, maybe I can share just this code because this is very interesting to just note. Any question? Any question? So of course all of them start at the middle because all of them start from zero. So the difference is just where it's ending at. So that's that. Let me just share this code in the chat section so you can just be able to use it. Though it's already there on the link I sent for the, sorry about that, for the GitHub. So I will update it because there's more data that I've added today so that you can be able to see that. Yeah. Oh, yeah, sorry. Yeah. So let us move on. So that's our coxcomb and our inverted bar chart, which has been accomplished using the code flip. So yeah. So data transformation. Data transformation. Unless there's a question up to that point. Anybody with a question? Okay. So we are now going to focus on how to use the deep layer package. We will also use data from New York City flights, 13 package. Um, this is also a data set that is available in our studio. So also use data from New York City package and use ggplot to install at package, load it up, and also load the tidyverse package. So let us just run that. So this is a nice time for you to ask a question. So I hope you guys are not floating a lot. But if you just write the codes and practice, you'll be able to understand what is happening. Remember, I'm just trying to introduce the various ways we analyze data. That's why I keep saying we're still touching base with R because we are still just learning how, if you get a data set, how are the various ways you can analyze that data. There's something called data wrangling. I know that's something probably you've already encountered in Python. That is something I want us to touch on. There are also some functions I would like us to use the loops that normally know the if else in R and see how that is accomplished. Is there something else? There is a whole, but I don't think we shall be able to accomplish this in that boot camp. But I I am planning to have a technical session soon on text mining with R. So I will share a link with you on the group, on the WhatsApp group. So if you're available, you can just come ahead and join, and we can see how you can be able to mine. You can be able to look at text as data and know how probably people in even places like Facebook or Twitter or Instagram, how they are able to use certain keywords um, to make conclusions from it, and from maybe an Instagram caption or something like that, or how to just probably even you can just look at a certain paragraph and analyze that data, and you can be able to know, so is this a type of person who is always speaking vulgar, this is a person who is always speaking about encouraging, just we can be able just to get the behind the scenes of for the social media sites that we use. How are they able to use those captions to guide the algorithm on what we should be seeing as a user. Everybody's Instagram is different, as much as it's the same. There's, for some people, who they mostly get motivational messages. So how are you able to do that? To filter that data, to be able to make sure that is what we are able to see, and they can be able to make conclusions from what you are talking about, your statuses on WhatsApp. Something that just arose the other time, where they are using that our text messages on WhatsApp, and you can find that it's being, when you enter certain platforms like Instagram, whatever you are looking for in WhatsApp, maybe even if you're not getting ads there, when you go to Instagram or Facebook, you get ads which are related to the conversation you're having with someone. So that is something that is very interesting with R. You can use text mining, and probably that's something which we can accomplish with Python. So I believe, yeah, so I will just share when that will be done, and then you can be able to join us if you can. So note the conflict messages. So we can see that are printed when we load the tidyverse. It tells us that the player overrides some functions in base R. If you want to use the base version of these functions after loading the player, we will need to use their full names, e.g. start filter, start lag. Yeah, so to just solve one of the conflicts, though we really won't get deep into this, I just wanted to show you that if you have a conflict, you can just do the start filter. You can also make conflict to be resolved. So yeah, it has acted up. So we'll just proceed. It won't affect us. So we can just look at our data set, flights. So this is our flight data. So New York City flight. So on time data for all flights that departed from New York City, that is JFK, LGA or AWR in 2013. Usage flights, that's how you call the data set. So data frame with columns has year, month, day, date of departure, depth, time, arrival time, actual departure and arrival times in the format of hours, minutes, or hours, minutes on local, wherever time zone. And then we have scheduled departure time or scheduled arrival time. So that's just, okay, I'm just saying it, but it's have departure delays and arrival delays in minutes. So negative means that it has an early departure arrival, and then carrier, two-letter carrier abbreviation. So see airlines that get that name. So that's something you can just look into. Flight means flight number. Tail num means plain tail number. And then origin, dest means origin and destination. Airtime, amount of air spent in the air in minutes. Distance between the airport. Hour and minutes, time of scheduled departure, hour schedule, date, hour of the flight, as a, yeah, date along with origin. So it also can be used to join flights data to weather data. Yeah, so that is that. That's our data. So let us analyze it. Let us analyze it. Okay. So of course you can print a table. You can also print the whole data set using the view flights. I don't think I have to run those, but those are just things I wanted to highlight there. So let us describe the type. Okay, let me just run the table. So we are going to describe values that we see in this table. Of course, int, we are going to describe these two values. Let me just make sure I first highlight them. Relevant. Okay. This int, double int name. That's what I'm just describing. And then you can see the 11 more variables: array delay, which is a double; carrier, which is a character; flight, which is an int; tail num is a character; origin character; destination character; airtime double; distance double; hour double; um, minute double; time, hour, date and time format. So that's basically what I'm explaining here, where we have the different type of type of each variable in the table. You have int standing for integers, dpl standing for double, char standing for characters, vectors or strings, dtm standing for date time or a date plus a time, and then others that are not there. You can have lgl, which stands for logical, continually true or false, and then factor, which stands for factor, represents a categorical variable with fixed possible value. We have date, which stands for date. Remember, you can have just a date without a time. So for our case, we have date and time. So we also need to explain the deep layer basics, the 5 key deep layer functions that allows us to solve the vast majority of our data manipulation challenges. Pick observations by their values. We have filter. This is something we have played around. We have reorder their rows, arrange, but you should also look into them. Pick variables by their name, select, create new variables with functions of existing variables, mutate, collapse any values down to the middle to a single summary, summarize. This is something we have looked at before. This can all be used in conjunction with group by, which changes the scope of each function from operating on an entire dataset to operating on it group by group. So we filter rows using the filter. Filter allows us to subset observation based on their values. The first argument is the name of the data frame. The second and subsequent arguments are expressions that filter the data frame. So we can select all flights on January 1st. So I'll just come and say filter flights month is equals to 1. So remember, these are operators. So where day is equals to 1. So it will filter all the flights of January 1st. Let us run that code. So that has been represented with a table. So you can see what has happened. Month 1 1, day 1 1. And this has a departure and that. So there are 32 more rows. So there are almost all those flights that were able to um, move on that day. That's a lot of flights. Or they're different airports, not just one. Okay, making sense. So to save the result, you need to use an assignment operator. So remember, that result has not really been saved. We have just looked at that data set. So you can assign a variable to that specific result. So I can just come and say Jan 1 is equals to that. So even I can now come here and say view instead of now viewing it as a table. We can just view it as a whole data set. Let us do that instead. So just run this. So you can see that is what has happened now. It's not showing me. That's just a data set which is a little bit better to look at than the table. You can see year, month, day, departure, and you can just be able to see all that. So you can see the different airports, the destinations, airtime, and all that. Yeah, so let us talk more about comparison operator, though when we shall be looking at functions all about if else, the basics um, that you should just know. Um, we shall look more into that comparison operators. So this include the less than or equals to, I mean the greater than and equal to, less, the less than and equal to, not equal to, and equal, which we have just used. So there's something I want to show you guys. So in case you're using numbers, for example, square root. So square root, this is a function in R that you can use to just find the square root. So raised to power 2, if I say the square root of 2 raised to power 2, expect the answer to be 2. So expect when I run this code, square root of 2 raised to power 2, it should actually be true. And I expect if I say 1 over 49 times 49 is equals to 1, this should be true. So let us see which outputs the console will give us when I run those code. So you can see the first one, it gives us a false, which is a little bit weird. So let us see how about the second one. It I said also false. So it has run the one below it accidentally. I'll tell it to just run that. So let me just make sure I run that. Okay, it's going all the way to the near. So you can see for this, however, it's giving us false as well. So what is happening? The outputs do not make sense. This is because computers use finite precision arithmetic. Instead of relying on the equal sign or operator, you can just use the near. So it will now come and say, if you know, instead of using just square root, you just say near is a bracket square root 2 raised to power 2, comma 2. So it will just be comparing, is this value near to this value? Is this value near to 1? So, and that's when it's ran that, I mean, can we just run it? When that is run, we now get that that outputs as true. And also for this, it now outputs as true because that precision has been given an approximate. Is it near to? Okay, give it that value. Yeah, so that is that. Any question up to that point? Any question up to that point? Okay, so let us move on to logical operators. So I think this is something that definitely at this point in your career you have encountered. So I will just use this image to quickly guide us so that we don't divulge so much into that. So Alvin, it's okay. There'll be a recording for the session, so you can just put to catch up there. So let us run. Okay. If I click. Okay. I have my impatience. Let me run it again. Yeah. So you can also just share this with you in case you need it. Yeah, so you can see this, it means, of course, the question mark means not. So if it is, let us just start with this and then we'll go to the negation of it. So it's x and y, so it's both x and y. So whichever it's if it's just x alone, we don't want that. If it's just y alone, we don't want that. We want the both x and y. So we have y and not x. So it takes every part of y but leaves any that is just x alone. So we have x and not y. So that's just what has happened. Has taken in x and left out y. And then we have just x alone. And then, no, I'm sorry. This is not x and this is just, okay, it's y and not x. So anywhere there's a mixture of x, it leaves that and only take whatever is just y alone. So the same for this, takes whatever is just x alone. So this takes the whole x, even if it's a mixture of y, because you haven't specified. You know, if you tell somebody you want beans, if they bring you beans and maize, they didn't go wrong because you told them you want beans. If you said I only want beans, not maize, they will have to remove all the beans in the maize and just give you beans. So that's just what you're doing here. So x or y, so it can be either x or y, but not both. You can either be male or female. and then I'm not being gender insensitive, but in this case, maybe you're told, or apply if you're only male and female. So, see if you're both, that opportunity is not for you. So, just why? You can be beans and maize, and or beans alone. So, it still has beans. So, yeah, so we have also eggs, all of it, the conjunction of both of it, X and Y or Y. So I think this is a conjunction. Wait, what did this type operator for when? Anybody who remembers, remind us, please. So yeah, so that is that. So let us find all the flights that, yeah, it's or. So I believe it's or as well, only that it's now both. It also has both. Okay, so let us find all the flights that departed in November or December. So I can just come and say filter flight month is equals to November the 11, or month is equals to 12. So if I run that, remember you can save it by assigning it a value. Okay, so for this we can't really be able to see because you can only see for um, month 11, so we are not sure if our data set is really conclusive or showing us what we need to know. So you can come here. Okay, so we can also rewrite this code, and then we shall view it here. We can also rewrite this code using the x percentage in xy. This will select every row where x is one value of the values in y. So instead of writing that, you can now come and say novdec is equals to filter flights month percentage in. So remember, this is assuming x and y. So it will say C, now declare the vector for x, I mean add the values for x and y. Now in a vector form, so it says C, where this is 11, comma 12, not deck. So let us put view here. So they'll be displaying as a table. So if we run this code, unless there's a question, so you can see what has happened. It has displayed. Let us just look at the month. So we can only see 11, 11. Let me just scroll down and see if I'll find my 12. Okay, let me just scroll. Yeah, so you can see it has also displayed 12. You can see this is 51,596 rows. So, yeah, that is a nice way of just doing that, because now in Newton you can say month. You can also look into, let us look what other values here you can use. You can look at the time, which departed around this time, the day, year as well. So instead of month, you can now put search, and you just want probably for a specific value. I feel like those are the values that you can probably get a good, the year, the day, unless you can think of another variable that can give us a good conclusion using that method. I'm open to hear it. So we can also use the Morgan's law, where we say not x and y is the same as not x or not y. And there's more here. Oh yeah. And not x or y is the same as not x and not y. So let's find, so this is just a mathematical rule or law. So let us find flights that weren't delayed on arrival or departure by more than 2 hours. You could use either the following two filters to do that. So what can we use? You can say filter flights where not arrival delay is greater than 120 minutes. So remember, we saw in our description that this is given in minutes. So where our arrival delay is not greater than 120 minutes, or our departure delay is also not greater than 120 minutes. So remember, we're trying to see flights that weren't delayed on arrival or on departure by more than 2 hours. We can also come ahead and say filter flights where array delay is less than or equals to 120 and departure delay is less than or equals to 120. So I believe that explains itself, and it should both give us the same answer. They should both give us the same answer. So let us use the arrange function. We see how that is done. So arrange rows with the arrange function. It takes a data frame and a set of column names or more complicated expressions to order by. So let us arrange flights with regard to year, month, and day. So how will that look like? Sorry about that. So we can see it arranges this with regards to with regards to year, month, and day, and you can see how that has been displayed. Though that is was how the data set was originally, so no big difference there. And then you can now say arrange descending to reorder the column in descending order. So arrange flights descending departure delay. So of course, the one with the most delay will be the first one. So let us see which one had the most. This one. So this departure delay had also, this is around 1,301 minutes. And that's a lot. Or I'm getting this wrong. Was the departure delay given in minutes? Because that's like departure. Oh, it's arrival in hours and minutes. Oh, okay, that's making sense. But it's still a lot. So that's around 13 hours. 13 hours in this case, and 1 minute. So there's one for 11. I can only imagine being delayed for that. Okay, it happens. Okay, so we also have, let us move on, select columns with the select function. It allows you to randomly zoom in on a useful subset using operations. Using operations based on the names of the variables. So let us select columns by name. So we are going to select flights, we're going to select year, month, and day. So if I run this, so you can see what has happened. It has just displayed that the year, the month, and the day. Full stop. Nothing else has been displayed. It has selected those three variables. We can also select all columns by year and day inclusive. So let us see how this will run. Let us see how this will run. So this will be it will be between year and day. So what is happening is, remember our data set here. If you just look at this, that's from year, month, day, departure time. So it's inclusive of now this year, month, day, from here up to here. So if I would have said year up to scheduled departure time, it would have printed those 5 variables. So let's select all columns except those from year and to day, from year up to day. So let us select all the other columns apart from those two. Note the negative sign before the year and the day. So how will that look like? So you can see start from departure time, schedule time, all the way. So let us look at our data set again. So you see, it's not exclusive of this. It starts from departure time, of which you have seen that is what has happened. So I hope that is understandable. If in case you have a question, you can drop it in the chat section or unmute yourself and ask. So there are a number of helper functions you can use within select. For example, start with function. So you can say start with, it selects only those which start with ABC. So it will match names that begin with ABC. You can also come and say select only those variables that end with and then XYZ. It will select only the names that end with XYZ. And then you can also come and say select anything, select what contains IGK. It will select names that contain IGK. It will match also this expression. If you want to maybe it's you're looking for a websites that have only education, stroke AC or whatever. So you can use that matches to specify the expression. So it selects variables that match a regular expression. This one matches any variables that contain repeated characters. You will learn more about, that is something we shall cover in string. So num range x1 to 3 matches. Also there's the num range, which can be used to select x1 to 3. It matches x1, x2 and x3. So you can just you can query the select and learn more on learn more on what can be done with the select. So you can see to give you subsets, column using their names and types. So overview of select features, full colons for selecting a range, exclamation for taking the complement of a set of variables, and or for selecting an intersection or the union of the two sets of variables. This is like the vector for combining selections. And then in addition, you can use selection helpers. Some helpers specify specific columns. For example, everything matches all variables. Last call selects last variable, possibly with an offset. These helpers select variables by matching patterns in their names. So starts with a prefix, ends with a suffix, contains a literal string, matches a regular expression, num range matches a numerical range. So we have all of matches variable names in a character vector. All names must be present, otherwise the out pointer is thrown. Any of, same as all of, except it throws no error if for names that do not exist. So this is something you can just look at and you can just be able to see because it has a lot of even gives you example. So iris is also a data set that is available in R. Things about flowers. So you can just look into that and just be able to see um make several operations with that. So yeah, you can even see the arrange, filter, mutate, rename, slide, summarize, things I'm also going to look at, but you see this, it can be able to easily guide you in case you don't understand anything or you understand something but you don't understand everything. So where was I? So I've done that. So we feel today we are going to hit our target. So what if I want to rename my variables? So I want to rename flight tail num underscore num. So remember we have that name here. Okay, it had already changed in mine, but in your dataset it should be tail underscore num. So if I want to change that to become tail num, I will now just use the rename function flights, call the variable to be equals to tail num, and that will change just like you have seen mine has changed. We can also use select, so I can maybe make it turn it the other way around. take it back to the original. So let me just run that. Mhm. So okay, so Control Z. Let me run this again. See if it will. Yeah, so it hadn't changed. I think that. So now it has changed. Okay, let me just view that. Mm, just give it a value G. Yes, not equals to. And then say view G. So if I now run this, so just give it a minute to view. In the meantime, I can just proceed. We can also use select in conjunction with the everything helper. This is useful if you have a handful of variables you'd like to move out of the data frame. Let's see, is it finished? Okay. So we have a few minutes left. So we can use the select everything. So any question up to there while that is finishing up or as we're winding up? Any question? What has happened? Any question up to that point? So I don't know what has happened. I don't know if the Art Studio has decided to end the class before I do. Let's give it till 9:55. If it refuses to resume or I cancel this. So I don't know, guys. I feel like the laptop has decided to end the class before for us. So is Mandela on this call?
Yes, I'm on the call.
So Mandela, I think I've encountered a technical issue, so I think we can end the class there. I will add to the assignment just to help you guys practice on what you have done today. Just remember to try and submit that so that I can just be able to gauge your understanding, and also it will just be able to challenge you to follow up on areas you have not understood. So I'm available via WhatsApp. You can just text me and I can be able to guide you where I feel I can't be able to guide via text, you can just plan a short call, um, online meeting, and I can just be able to guide you. Probably you have encountered a blocker, you can just be able to plan that. So don't be afraid to reach out. Yeah, and also just help each other out. Don't be total strangers to each other so that you can just be able to understand this better. There's a lot I still need to show you, and I hope by the end of the boot camp I will be able to. And what I want to be able to, you just have the responsibility to look, to search for it and just study. You have all the resources, the online resources, so just tap into that. And probably if you're learning something and you're not understanding, even if it's on your own, you still have the you're still allowed to also just ask me and I will answer. So Richard, your hand is raised up. Richard Wambua, your hand was raised up. Do you have a question?
No,
Okay. So I think we can call this the end of our class. So if there's nobody with a question, let's meet on Friday. Try and be early and try and do the assignment.